Hi and welcome to this short clip having a look at the electron configurations of chromium and copper and dealing with why they're slightly anomalous compared to others. So to do this, let's have a quick look at electron orbital filling using an example where repulsion within an orbital affects the ionization energy. So if we fill the orbitals, you'd expect them to fill like this, with 1s filling, then 2s, then 2p, but the electrons fill in the p subshell so as to avoid repulsion. So going to 3s and then 3p, something similar happens there. So in the 3p subshell, there's an orbital where there are two electrons next to each other. That's a full orbital. So therefore these electrons are more vulnerable to being removed due to repulsion. So this is obviously sulfur, this particular example that we're looking at. So what this means is that it takes less energy to remove an electron from sulfur, so the ionization energy is a little bit lower than expected. And this is the orbital we were talking about. So both those electrons experience repulsion, so it's easier to remove one of them. So if we look at chromium and copper, I've highlighted them in this graphic in red. And what happens is an electron will be promoted from 4s into 3d so as to avoid repulsion and to make the atom more resistant to ionization. So these are the expected and observed configurations. Less electron repulsion across 3d and 4s occurs in the new arrangement for chromium, and for copper, less electron repulsion in 4s. So remembering that 4s is a lower energy orbital, and therefore it's vulnerable to removal of an electron. If you can take the repulsion away, that removes one of the factors that makes it easier to remove that electron. Okay, thanks for listening. Until next time, see you soon.